Hello, everyone. Welcome to the next lecture. So, guys, today we are going to be discussing electron configuration, and then we are going to be discussing about orbital diagram, and after that, guys, we're going to talk about some periodic table trends. Okay, so trends on periodic table, and this includes atomic size, ionization energy, and electron affinity. So, starting with electron configuration, guys. First, so this topic, guys, is going to discuss what we can simply call the address of electron in an atom. So basically, we are going to learn what is the location of electron inside the atom. We do know that in the atom, in the center, we got the protons and neutrons, and this part is called the nucleus. This is where most of the mass of the atom is concentrated, whereas we know that the atom is sitting outside in these shells. So electrons are sitting here, and there can be one shell, two shells, three shells, four shells, five shells, depending on how big the atom is, how many electrons it has. So electrons are sitting here on these orbits or shells. So guys, these um, orbit, they're also called a shell. For our understanding, guys, we're gonna make an analogy, and we're gonna think of an atom like a building, which has on the ground floor, that's where your nucleus is. Then you got your, then you have, so below, so basement is where your electrons, where your protons and neutrons is, that's your nucleus. And then on the ground floor or the first floor, that's our first orbit. That's where the electrons are going to be situated. Okay, so I'm going to be calling this floors as well. Again, this is in chemistry. Don't call it floor. This is just one analogy that we're just making here. Okay, so uh, yeah, the electrons, guys. The different floors can accommodate more than, I mean, different numbers of electrons. So like the first floor can keep 2 electrons, the next floor can keep 8 electrons, and so on. Okay, so we're going to be discussing, guys, on how we have divided the address of the atom, of the electron in an atom, by giving some different informations in the electron configuration. Okay, so we have different types of rooms on each floor. Okay, so if we say that we have different floors, which we also call orbit. So each orbit. So let's say if I say the first orbit or the first floor or the first shell, it has a type of room, and that room is called room S. Now, of course, we are calling it room, but actually they should be called an orbital. So not orbit, okay? Orbit was the floor number. Now, inside, or the first floor, the first orbit has S orbital inside. And that orbital, you can think of that as a room. And guys, the actual term, I mean, another term for orbital is subshell. So if you guys remember, the orbit was called shell. This is your first orbit. Inside the first orbit, you have S orbital. Now, on the second orbit or second shell, you have room S as it is. So, like just like the first floor, second floor also has room S, but it has additional room called room P. Now, in case you guys are wondering what does this S and P mean, guys, these are different shapes of orbitals. So different shapes of orbitals have been given these different names like S, P, D, and F. Okay, and they have different shapes. As in, uh, S is spherical in shape. So S is spherical in shape. So what does that mean, guys? Think of this as if uh, that in the center you have your nucleus. This is your nucleus, and then outside, guys, there's a region where the electrons can be found, and that region is spherical in shape. So think of this region being a sphere, and you can find electrons in that sphere. So this is your S shape or the S orbital, or it's also called the subshell. So now, as we said, the first floor has the S orbital, As you go to the second floor, you're going to have another s orbital. So on the second floor, there'll be another spherical shape, and that spherical shape is also the s orbital. And in addition to the s orbital on the second floor, you have another orbital which is called orbital p. And that orbital p, guys, has a dumbbell shape. Now you're going to learn more about this if you're going to take a general chemistry class, okay? But for right now, this is as much information as I can give you here. That this is the electron cloud as well, which starts from the second floor onwards. So if I'm on the second floor, guys, on the second floor, there's a chance of finding the electron in this shape, okay? And this p orbital is not just in this one orientation, but in the x, y, and z-axis, okay? So now I'm not going to be testing you on any of that on the exam. This is just to give you an idea of what is happening inside the atom and what do we mean by these terms orbitals. So orbitals are basically the electron clouds so which shows the probability of finding the electrons, okay? And those regions, the probability cloud can be spherical shaped, then we call it S. If it's dumbbell shaped, then we call it S. We call it P. So let me see that again. So when it's spherical, we call it S. When it's dumbbell shaped, we call it P. Now, when we have more complex shapes, then it's a D. Even further, we have F. So, but they're again different shapes, but they mean the same thing. They're basically showing us the electron cloud. So, guys, S and P, this is the orbital or a room or a subshell that you can find in the second orbit or second shell or second floor. Then when you go to the third floor, is on the third floor, you can find the same S, you can find the same P, but then you also find a new orbital, which is called D. As you go to the fourth floor, as you would expect, you have the same S, P, and D, but then you have an additional F orbital as well in addition, okay? So now, when we are covering the electron configuration for our atoms, then this many orbitals are good enough for us to take care of all the electrons that we have in our all the elements. Okay, so that's why we don't go further. So now the idea is, guys, that when the electrons go and they want to go inside the atom, then they first want to occupy the lower shells first. So the electrons will first go to the first floor. Once the first floor is complete or is full, that's when they go to the second floor. If the second floor is complete, then they go to the third floor and so on. So let's begin, guys, with the electron configuration of the atom. So let's see how we're going to write the electron configuration. We're going to begin with the very first example, which is hydrogen. So guys, hydrogen, so the first thing we need to answer here is that hydrogen has how many electrons? So hydrogen has one electron. So how do we know hydrogen has one electron? You go to the periodic table, you go here, you see hydrogen. If I ask you hydrogen has what atomic number, you're looking at the smaller number here, okay? So 1 and 1.008, so 1, this is the atomic number. And guys, if you have a neutral atom, meaning it does not have any charge, like hydrogen, it's going to have the same number of electrons. So hydrogen has one electron. So let me ask you carbon. Carbon, you see you have 6 and 12. So this 6 is the atomic number. This is how many electrons carbon has. So all the numbers you see on the top, that's the electrons that atom has got. Okay. So now when we go to hydrogen, it has one electron. So now let's write down the electron configuration for hydrogen. So guys, hydrogen has its one electron. It goes to the first floor. On the first floor, which room does it go into? If you remember, the first floor only has room S. Okay, so only room S. So first floor, it goes to room S, and then it has only one electron, and it places that one electron there. And that's how you show the electron configuration for an atom. So when you're writing electron configuration, guys, again, this number in the front is the floor number, or which is the orbit number. Then this S is telling you the orbital, or the subshell, or the room. And then this number on the top is telling you the number of electrons. Okay. Now, guys, there's one more thing that we need to learn before we go to next examples. So, guys, these S, P, D, and F orbitals that we have. So these are the list of the orbitals that I'm making. So guys, these orbitals, they have fixed, no, not fixed, but they have a cap of how many max electrons they can keep. So like S can keep maximum 2 electrons, no more. If you have 2 electrons on S, it's full, go to the next room. P can take 6 electrons. D can take 10 electrons. So guys, if you notice, you see there's a jump of 4 electrons each time. So from 2, you add 4, you go to 6. 6, you add 4, you go to 10. What do you expect the next number will be? It will be 10 plus 4, 14. So this is the cap of how many electrons these orbitals can keep maximum. Okay, now we did the hydrogen, so now let's do the next example, which is let's take a lithium. So guys, lithium has 3 electrons. Again, how do you know it has 3 electrons? You go to the periodic table and you see here lithium has 3. That's 3 electrons. So guys, lithium has 3 electrons. So what do we do? When you write the electron configuration for lithium, you go to the first floor, you go to room S because that's the only option, and then you put how many electrons? You see you have total 3 electrons. So can you put 3 here? No, you cannot, because S can take maximum 2 electrons. So you stop at 2. So you see S can take max 2 electrons, and that's it, no more than that. So if the first floor, first of all, fourth floor can only take 2. So first floor only has room S, and S can only take 2 electrons. So if you put 2 electrons there, that floor is full. Then what do you do next is you go to the next floor, which is the second floor. So when you go to the second floor, again, which room do you go to? So guys, every time you need to tell the floor number and the room type, and then how many electrons, okay? So you go to the second floor, and again, if you remember, the second floor has S and P. So the electrons will first go to the S, and then they will go to P. So you have 2S, and on the 2S, you're going to put how many electrons? See, lithium has total 3 electrons. You already placed 2 on the first floor, so the second floor will get the 1 lost electron. So now you got total 3 electrons. So guys, if you notice here on what we have done, so we have, if we confirm our electron configuration, we got 1s2, 2s1, and that's your final answer. Okay. So now, guys, what we're going to do is we're going to look at some more examples. Okay. So now let's go to carbon. So carbon has 6 electrons, meaning we go to the first floor. On the S, you put 2 electrons, then you go to second floor, and then you again have S, and then you place 2 electrons. Why do I not put 4? Because S has a maximum cap of 2 electrons. You cannot put more than that. So 1s2, 2s2, that's total 4 electrons. We got 2 more on carbon. So now you go to, on the second floor, if you remember, on the second floor, you have S and P. So if S is full, you go to P. So that means you go to the second floor and you go to the P orbital. So guys, remember, whenever you're writing this, every time for each orbit, you need to mention what floor number you're on. So you cannot just do 2s2 and then P something. You have to put 2 in the front again. So this is 2 plus 2, 4 electrons. And then how many more should I put here? 2 more, and that will take care of the 6 electrons. So you can see here, 2 plus 2 is 4 plus 2 is 6. And we have carbon has 6 electrons, and that's what we want. So this is the answer for carbon. Now, let's go to sodium. Sodium has 11 electrons. And again, we know that from the periodic table, sodium has 11 electrons. So sodium, when we write the electron configuration for sodium, guys, we go to first floor, S2, so 2 electrons. Then you go to 2S, you put 2 electrons. Then you go to 2P. How many electrons do we put here? See, this is already 2 plus 2, 4. And we have total 11 electrons. So we still have 7 more electrons to go. So if you remember, P can take maximum 6 electrons. So you put 2p6 here. You cannot put 2p7 because 2p or P orbital or room cannot take more than 6 electrons. So far you got 2 plus 2, 4 plus 6, 10 electrons. You still got 1 more. So what do you do next? Do we have any other room on the second floor? No, we don't. So we go to the next floor, you go to the third floor, and you go to room S, and you place 1 electron. So this is your electron configuration for sodium. Just to confirm, we got 2 plus 2, 4, 4 plus 6, 10, 10 plus 1 is 11. So we got total 11 electrons, and we're all set. Okay. Now, if we try to write down, guys, the order of the floors and orbits, guys, We know on 1s, after 1s you have 2s, after 2s you have 2p, after 2p you have 3s, after that you have 3p. And if you remember, let me make that list again here. So first floor has s, second has s and p, third floor has s, p, and d. Let me correct that. This is p. So s, p, d, and then the fourth floor you have s, p, d, and f. So now, guys, speaking of what the trend, what we were talking about, 1S, 2S, 2P, then 3S, 3P. After that, it should be 3D. I mean, you're thinking correct that after 3S, it's 3P, and after 3P, it should be 3D. But guys, a story changes a little bit here, and there's a change. Whenever, guys, you're trying to go from SP to the D orbital, what happens is the S of the next floor actually comes in before the previous d orbital. And why is that? It's because for some reason, 4s energy is less than 3d energy. And that's why 4s is going to be filled in first. So after 3p, guys, we'll go to 4s and then we go to 3d. Now, this is what you should have in your notes or have this memorized. Because you should know this. And with this, guys, we can take care of the first 30 atoms, and that's all what I'm going to test you on the exam, the first 30 atoms. So first 30 atom meaning only up to zinc. So if you know this trend so far like that, then you are covered for the first 30 atoms. So um, again, just to summarize, when you go from 3s, 3p, and you want to go to 3d, actually 4s comes in first. Now, just to remind you guys again, how do we fill the electrons, guys? You go to the lower energy first. So if I try to draw an energy diagram, the 1s is very low energy, and that's why it's filled first. Electrons like to go to more stable and less energetic orbitals. So guys, the orbitals that are lower energy are more stable. So electrons want to be more stable. They want to go to 1s first. Then they will go to 2s. When I draw 2s higher than 1s on the y-axis, what does that mean? That means that 2s has more energy than 1s. So electrons will first go here. If this is full, then they will go here. Okay. Now after 2s, what do you expect? We have 2p. So we have 2p sitting here. I'm just drawing 2p bigger here because 2p can take more electrons, okay, than 2s. After 2p, we expect 3s. After 3s, we expect 3p. After 3p, we expect 3d, but the problem is 4s comes in first, and then 3d comes back. Okay, so just to show you here again, this is what is happening here. Uh, uh, the electrons are getting filled by the energy level of the orbitals. Okay, so yes, let's take an example for that. So let's pick scandium, guys. Scandium has total 21 electrons. Again, how do I know? I go here, scandium is 21 electrons. So if I ask you on the exam to write the electron configuration for scandium, this is what you're going to do. So you're going to take the scandium and you're going to write, let me erase that. Okay, so what we're going to do is, scandium has 21 electrons. We go to 1s, we put 2 electrons. Then you go to 2s, you put 2 electrons. Then you go to 2p, and you put 6 electrons. You see, so far we got 2 plus 2, 4, 4 plus 6, 10 electrons. Then we go to 3s, we put 2 electrons. Then you go to 3p, we place 6 electrons. Now again, let's count how many electrons do we have so far. So this was 10 so far. 10 plus 2, 12, 12 plus 6, 18. So we have 18 electrons. After this, guys, where do we go? Remember, after 3p, we have 4s and then 3d. So first I'll go to 4s. So when I go to 4s, how many electrons do I place here? Up to this point, up to 3p6, I have 18 electrons. So 2 more will make it 20 electrons. I still have 1 more. After 4s, remember we need 3d. So after 4s, we have 3d. And how many electrons do I place here? Up to 4s2, we got 20 electrons. We got 1 more. So 3d1. Okay, so I hope this makes sense, guys, here. Now, what we need to do is we need to talk about the ions. Okay, now for ions, guys, what do we mean by ions, first of all? So scandium, if scandium becomes scandium plus 2, what does that mean? This is an ion. So this is the neutral atom. This is neutral scandium. This is the ion, specifically cation. Okay, so positive ion is called cation. So what does that mean, guys? Scandium plus 2 means what? That it has gained 2 electrons or lost 2 electrons. See, scandium is positive 2, meaning it has become positive, meaning it must have lost something negative, and negative is electrons. So the electrons here is 19 electrons now. Now, guys, something to remember here, and a very, very common mistake or confusion on the exam. So scandium plus 2, uh, who has lost 2 electrons, the question is, where did they lose the electron from? Like, can we remove any electron from here, any of the electron from this electron configuration? So we need to tell where is the electron lost from. And you need to remember, guys, that the electrons are lost from the outer shell or outer floor first. Okay, so if I ask you which one is the outermost floor here, what are you going to say? Which one is the outermost floor? Is this the outermost, or is this the outermost? Again, remember the outermost, meaning if I draw the floor, so this is the nucleus, which has protons and neutrons. If I start drawing the floor, so this is my first floor, second floor, third floor, and then I've got the fourth floor, like in this case. So for scandium, on the fourth floor, it has 2 electrons sitting on the fourth floor, and on the third floor, it has the 3d1 electron, it has 3p6, it has 3s2. So it has 2 plus 6, 8, and then 1, 9 electrons sitting on the third floor. So my question is, which electron is going to be lost? Is it going to be the electron sitting on 3d, or is it going to be the electron sitting on 4s? Again, as I said, the electrons must be lost from the outer shell. And guys, outer shell is also called the valence shell. You got to remember that. You're going to be tested on that on the exam. So valence shell or outer shell is the same thing, okay? And similarly, inner shell or inner electrons are also called core shell or core electron. Okay, so valence shell, so outer shell or valence shell, inner shell or core shell, they mean the same thing. So guys, if I ask you which one is the outermost floor, then simply the answer is fourth floor is the outermost floor, okay? So if this is first, second, third, and fourth floor, this is my outermost floor, this is where you're gonna remove the electrons from. So guys, scandium plus 2 has lost 2 electrons, so you need to remove these 2 electrons. You cannot remove electrons from 3d or 3p or 3s or 2p or 2s or 1s. Okay, so if scandium had lost 3 electrons, then yes, then you will remove 2 from here and then 1 from here. Okay, so even when you have 3s, 3p, 3d, and if I ask you where to remove the electron from, first you will remove from 3d and then from 3p and then from 3s. But in this case, of course, since you're losing only 2 electrons, they must go from the outermost one, and that's the fourth floor. So imagine this, guys. Imagine you're in a building and there's an alien attack from the outer space. Then tell me which floor is going to be affected first. It's going to be the topmost floor, the outermost floor. So that's why when 2 atoms are reacting with each other, the electrons that matter the most are the outermost ones. Okay, so in this case, that's the forest one. So if guys, if we do for scandium plus 2, if we try to write the answer for scandium plus 2, guys, the answer will be 1s2, 2s2, 2p6. So I'm just copying what I have here on the top. Okay, 2p6, 3s2, 3p6, and now we're going to stop here and think this 4s2 is gone because this is scandium plus 2. It has lost 2 electrons, which you're removing from 4s2. So I'm not going to write that anymore. After 3p6, I'm just going to write 3d1. So guys, this is what you got to remember, that when you're doing the positive ones, so whenever you do the cation, always write the neutral atom first, and after that remove electron from outermost shell. Okay, so let me now show you the incorrect way of doing this. Okay, so let's see on the exam I ask you, what is the electron configuration for scandium plus 2 is going to be. So I'm going to discuss the wrong way of doing this. Okay, So on the exam, I ask you, write the electron configuration for scandium plus 2. I don't ask you for scandium. So you don't have that electron configuration written already because the question directly is saying scandium plus 2. So you think in your head that scandium has 21 electrons, so scandium plus 2 must be 19 electrons. So let's do one thing. With 19 electrons, let's write the electron configuration. Again, guys, I'm reminding you, this is the wrong way of doing it. So scandium plus 2 with 19 electrons will look like this. 1s2, 2s2, 2p6, 3s2, 3p6. This is 18 electrons so far. 2 plus 2, 4 plus 6, 10, plus 2, 12, plus 6, 18. That's 18 electrons. And then I have just one more. So after 3s, 3p, technically I should go to 4s and put one electron here, 4s1. You see, without me looking at the neutral atom and deciding where the electron should be removed from, and I simply just start writing electron configuration for scandium plus 2, which has 19 electrons, I'm going to get this electron configuration where you can see that it's different from what we got earlier. Earlier, this is the answer we got. Tell me what is the difference, guys, in these two answers. This is the correct answer. This is the incorrect answer. What is the difference? The difference is here. You see this is 4s1 and this is 3d1. This is the correct answer. And again, guys, why is that one correct? Because here we followed the right rule. For anything positive, I should first write down the neutral atom, which we did, scandium. We wrote down the electron configuration. And then I have to remove the electrons. So I have to remove 2 electrons and I'll remove from the outermost. So I'll go to 4s2 and remove these. And then I'm going to just rewrite that. And I'm going to not write that 4s2 anymore. And everything else, I'm just going to copy that here. And this is the right way of doing this. The incorrect way is when you simply write scandium plus 2 and you just do the math where scandium is 21 electrons. So scandium plus 2 must be 19 electrons, and you start writing electronic configuration as it is. That is incorrect. And guys, this is a very common mistake on the exam. You're going to be seeing this, something very similar on the exam for sure. So make sure you guys understand this part, okay? All right. Now, when it comes to the negative ones, so the negative ions, those ones are easier. Over there, you don't have to write the neutral atom first. For example, if you have oxygen -2, you just simply write oxygen is 8. So original oxygen is 8 electrons. Oxygen -2 is going to be 10 electrons. So I'm simply going to do 1s2, 2s2, 2p6, and I'm done. That's it. So here it does not matter because you're adding electrons, you're not removing them. It's when you're removing them, you must follow this rule of writing neutral atom first and then decide where to remove the electron from. Okay. Now, that being done, guys, the next thing, guys, we're going to talk about is what we call the orbital diagrams. Okay. So this is again something connected to electron configuration. So we need to know electron configuration first. And now what we're going to do is we're going to talk about orbital diagram. So guys, orbital diagram, this is just like electron configuration, but we're actually going to show electrons are sitting exactly how in the orbital. Okay, so when we say hydrogen is 1s1, that is electron configuration, writing 1s1. But showing the orbital diagram, what does that mean, guys? So for hydrogen, we're going to show, so we're going to be showing each orbital as a box. Okay, so I'm going to label this as 1s. And the way we show electrons in orbitals in the orbital diagram is by showing the arrows. So you make an arrow pointing up and an arrow pointing down. Those are two possible. So if you have a box, this is representing an orbital. You can put the electron pointing up and you can put the electron pointing down. That's me showing 2 electrons. If I have to show 1s2, this is how I would show it. I have to show 1s1, this is how I would show it. Now, there's another way to show 1s2. So when you're writing the arrow, you don't have to you don't have to draw the complete head, but just half. And this is also okay. It's also common that you're going to see 1s2 written without a box, just a line, and then you show 2 electrons like that. Everything is good here. So you can show it as any of these 3. So now, guys, what we do is we're going to be talking about um, the other examples. So let's Go to carbon. Carbon had 6 electrons, and this guy was 1s2, 2s2, 2p2. So let's talk about that one. So you go to the first floor. So on the 1s, you have 2 electrons. On the 2s, you have 2 electrons. Now, remember one thing, guys. Uh, S can take 2 electrons, and that's why S. Why is that? Because S has only one orbital. P can take 6 electrons, and guys, remember, each box can hold 2 electrons max. Okay, uh, so P can take 6 electrons. So what do you think? How many boxes does it have? It has 6 boxes. So you can draw 6 boxes like this. I mean, 3 boxes like this, holding 6 electrons, or you can draw separate 3 boxes, and this can be shown as your p orbital. So guys, when we show when we say 1s, you just make one line or one box. 2s, one line or just one box. And when we say 2p, you cannot just show one line or one box. This is all 2p. Okay. And if you remember earlier when I said 2px, 2py, 2pz, that's what it meant. Again, not going into too much detail about that because you're going to learn that in Gen Chem when you take advanced chemistry. Okay, so guys, just to mention again, when you're showing S, you only make one box or one line, or I mean one dash. But when you show P, then you make 3 of them. Can you tell me D, which can take 10 electrons? How many boxes do you expect? Each box can take 2, so I expect 5 boxes. Okay, so this box will now be divided into 5 sections. So that's how D is going to look like. F can hold 14 electrons, so it's going to have 7 boxes. Now going back to carbon, 1s2, 2s2, now 2p2. 2p2, guys, when you have 2 electrons and you have all the 2p at the same level, guys, by same level, I mean, when you draw them like this, they're all at same energy level. So guys, electrons want their own space. So if electron goes here and the second electron has to come in, it will go to its own room. It wants its own room, if possible, okay? So if it was possible for 2p electron to be just one electron in each orbital, that's what it'll prefer. So if you do it, let me do it the wrong way, okay? So these are my 2p, 2p, 2p. So 1s2, 2s2. Now if I do this 2s2, 2p2 like that, this is incorrect. The electrons must, if there's space, the electrons want to go by themselves first. And if needed, if there will be more electrons, then yes, you will start pairing them up. Okay, so let's take an example of that. So if I have oxygen, which is 8 electrons, it's 1s2, 2s2, and 2p. This is 2 plus 2, 4, so this is 2p4. So now if I try to draw 1s, 2s, and then 2p, so this is 2p, 2p, and 2p, and this is 1s and 2s, is this is 1s2, 2s2. When we say 2p4, this is what we have to do, guys. One electron here, next electron here, third electron here. Now the fourth electron on 2p, you will start again from the front, and you'll pair the first orbital. Okay, so that's how you're going to show 2p4. Okay. Now, guys, what we're going to see next is we're going to discuss 2 exceptions among the first 30 atoms, okay? Which is chromium and copper. Let's look at them and how they behave a little differently, okay? So, guys, chromium has 24 electrons, and if I ask you to write the electron configuration, it's going to be 1s2, 2s2, 2p6. That's 10 electrons. Then 3s2, 3p6, that's 18 electrons. 4s2, 20 electrons. 3d4, 24 electrons. So this is the electron configuration. Now let's draw the orbital diagram, and that will tell us why electron configuration of chromium is not this. It changes a little bit. So I'm on 1s, 2s, 2p. This is all 2p. Then I have 3s. Then I have 3p. Then I have 4s, and then I have This is my 3D. 3D, 3D, all of that is 3D. Okay. All right. Now, you actually, when you're writing these, when you're going to see them in the textbook, guys, you might actually not see 2p written like 3 times, 3p written like 3 times. Usually, you're going to just see this labeled as 2p for all of them, 3p for all these three, and then 3d for all of these. Okay, so now let's start filling this, guys. So 1s2, 2s2, and then 2p6. You see, 2p is all full, 2p6. So they all are going to be paired up. Okay, then you have 3s2, then we have 3p6. Again, guys, we know it's already full, so you can go in one go and just fill them up. But otherwise, you know how to first do one in each one, and then if you need to pair up, then you go and pair up. And then you have 4s2, and then you have 3d4. This is what this is going to look like. Now, guys, the thing is that when the chromium looks at this 3d4, guys, atoms like half-filled or fully filled orbitals. What does that mean? So guys, as you know, 3D can take 10 electrons total. So this is, I'm trying to show you 3D, okay? 3D either prefers this. You see, this is half-filled orbital. So the full 3D, which can take 10 electrons, has 5 electrons. So this is half full. Another option is that 3D will be fully filled. By fully filled, I mean it'll have 10 electrons. So guys, chromium has 4 electrons here in the 3D. It wants to make it look like this. So how do you think this is achievable without, of course, adding a new electron from outside? It's done by moving this electron that is sitting here, guys, from 4s will be moved here. So guys, do all atoms do this? No. In the first 30 atoms, only the chromium and copper are the one who are able to do this. Okay, so do not impose this to all the atoms that you ever see. This is only for chromium and copper among the first 30 atoms. Oops, why is this not working? Okay, so now guys, let's look at the chromium again. So I'm going to rewrite this, okay? So now I hope I hope you understand this part, guys, that this electron has been removed and this electron has moved here. So you see how happy now chromium is going to be by looking at its 3D being half filled. So guys, this is what has happened. So now we have to go back and change our electron configuration. So on the exam, guys, if I ask you the electron configuration for chromium, I'm not going to be reminding you with this orbital diagram. It's your job to remember that you're gonna that the chromium and copper are the one who move their electrons around. Okay. Oops, why is my eraser not working? Okay. Okay. So guys, let's rewrite this. It's 4s1 and 3d5. Now guys, it's going to be your job to work on copper, which has 29 electrons. Something similar happens. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. This is 20 electrons so far, and then it should be 3d9. You see, guys, copper is also in the same dilemma. It can move its 4s2. It can move one of the electron from here and move it to 3d, and this will become 10, and that's what it actually does. Okay, so when you see actual copper, it's not 4s2, 3d9. It's actually 4s1, 3d10. So this is the actual electron configuration for copper. So guys, if you understand this whole topic, electron configuration orbital diagram, expect few questions on your exam on this. Then guys, as I said before,